Hello, 5th graders. Welcome to lesson 1.8, Relate Multiplication to Division. In this lesson, we will be learning how to use multiplication to solve division problems. First piece of information that you will need is a clear understanding of what inverse operations are. It is the opposite operations that undo each other. So the inverse operation of multiplication is division, and the inverse operation of division is multiplication. Same goes with addition and subtraction. They are the inverse operations of one another. It is also important to know the vocabulary when working with multiplication and division problems, recognizing in the first example that 3 and 8 are both factors, and 24, the answer to a multiplication problem, is called a product. In the division number sentence, 24 is a dividend, and it's being divided by 3, which is our divisor, and the answer to a division problem is called a quotient. In this first example, 90 divided by 6, what I'm going to do is I'm going to break apart the 90 so that way the numbers I break it into is divisible by 6. And I will show you what that looks like. First, I'm going to draw a box, a rectangle, and place my divisor, 6, to the left of this rectangle. Now, I have to think about how can I split up 90 so that way it's broken up into two numbers that's divisible by 6. I know that if I break up 90 into 60 plus 30, 60 is divisible by 6, and 30 is also divisible by 6. And if I add 60 and 30, I get back to my original dividend, which is 90. So I'm going to break up this box into two pieces relative to this value, so 60 and 30. Imagine this as how we traditionally set up our division problems, right? And adding a plus sign right there in my rectangle. Okay, so now I'm going to divide 60 by 6, which is 10. So I'm going to write the 10 above the 60. Again, my plus sign. And then thinking, how many times does 6 go into 30? 5 times. Now, what do I do with that 10 and that 5? Well, that 10 and that 5 are called partial quotients. And with my partial quotients, I must add them together. So 10 and 5 equals 15, which is my complete quotient. So 90 divided by 6 equals 15. This is how you can model breaking apart the dividend. I'm going to actually show you how you would write it as an equation. So again, working with the same division problem, 90 divided by 6. From the previous problem, I know that I can break apart 90 into 60 and 30. So I'm going to write 6 times 60. I'm sorry, hold on. Oops, my mistake. 6 times 10, using the 10 to make 60, in parentheses, plus 6 times 5 to get to 30 will give me 90. And if we actually solve this, 6 times 10 is 60, 6 times 5 is 30, which does equal 90. So that's just showing you how we're breaking apart that 90. And remember, your divisor should be the first factor in your multiplication in your parentheses. And just like how we did in the previous example, when we added 10 plus 5, we're going to add the 10 and the 5 to give my answer of 90 divided by 6 equals 15. In the second example, I will be solving for 52 divided by 4. Again, I'm going to break up my dividend 52 into two addends that are going to be both divisible by 4. So I will model that by drawing my rectangle and then thinking to myself, how can I split up 52? It is easiest to always try multiplying your divisor, in this case 4, by 10 and seeing what that difference is. So if I multiply 4 by 10, I get 40, and then there's 12 left to get to 52. So 4 goes into 40, and it also goes into 12, so I'm going to break that up into 40 and 12, because together it makes 52, and 40 and 12 are both divisible by 4. Then I'm going to place my divisor 4 to the left of my rectangle, my model, and then divide 40 by 4, which is 10. Always write my addition symbol as well. And think to myself, how many times does 4 go into 12? 3 times. Again, 10 and 3 are my partial quotients. And 10 plus 3 equals 13. So 52 divided by 4 equals 13. And now I'm going to add a little bit something that we didn't add to the first example problem. So this whole lesson is about relating multiplication and division. So I have my division sentence here, 52 divided by 4 equals 13. Now, how can I write that as a multiplication problem? Well, I can write that as 4 times 13 is 52. Okay, so now I've modeled it for you, and then I'm going to show you how to write it using an equation. Alright, so same problem, 52 divided by 4. I'm going to write my divisor first in parentheses times 10. That gets me 40. Now I have 12 left. So I need to add 4 times 3. That gets me 12. 40 plus 12, which equals 52, which is my dividend. Equals 52. Yep, everything checks out. Now to be able to find the actual quotient, again, add the factors, 10 plus 3, which equals 13. So that must mean that 52 divided by 4 is 13, and I can say that 4 times 13 equals 52. So when I'm writing these equations, I expect to have a division sentence and a multiplication sentence to show the relationship and the inverse operations. Noticing how I can divide 52 by 4 and get 13, and then I'm undoing that by multiplying 4 times 13 to get back to 52. Alright, for this one I'm going to only do an equation. You can pause the video and try this one out for yourself and then check back in with the video to see how you did, or you can follow along as I will demonstrate how to solve this one as well. And I wrote the wrong operation symbol. It should be 72 divided by 4. My apologies. Whoops, I hope you didn't pause the video that early then. Alright, so 72 divided by 4. Let's split up 72 into two addends that are going to be divisible by 4. Again, always start off with 4, or whatever your divisor is, by 10 and see what that gets you. 4 times 10 is 40. 72 minus 40, I think, is 32. And can 4 go into 32? Yes, it can, and it can do it 8 times. So I need to put my addition symbol here, and then 4 times 8. So together, 4 times 10 is 40, plus 32, which equals 72. And that's what I need to write for my equation. Something that I want to add is that when I recommend multiplying it by 10 first, if you've noticed that there's still a great number left after you've multiplied by 10, you can try 20 or 30 or even something greater, okay, depending on what your dividend is. I always recommend starting off with 10 first and then working your way through that, okay? So now I've written 72 divided by 4, and I know that is 10 plus 8, which equals 18. Now to write a multiplication sentence that also shows that relationship would be 4 times 18 equals, 72. All right. Lastly, I can show this by making an array, and that would be using my multiplication sentence. 4 rows of 18. All right, so that is 4 rows with 18 in each row. So that is 4 times 18, and I get 72. Here are your practice problems. Please use multiplication and the distributive property to find the quotient. For numbers 1, 2, and 3, I expect you to have the equation format that we have been practicing, as well as the multiplication number sentence that shows the inverse of that, the division problem. All right? Enjoy the rest of your day.